The growth of big data has surpassed our ability to store it, and now it has even grown past our ability to process it efficiently. Compute, memory, storage, and networking components have all gone through multiple iterations of design improvements. Specialized processors, in-memory compute and tiered memory, NVMe SSDs, and smarter NICs have all been designed to increase system performance. However, the bottleneck that remains is in the interconnect. PCI Express is now outdated and poorly equipped to handle the heterogeneous architecture requirements needed to address the big data challenges. At Elastics.cloud, we are taking a top-down approach in creating the next generation system architectures. We are combining smarter component-level connectivity and system-level intelligence to create more adaptable systems that will give our customers increased utilization, performance, efficiency, and overall lower TCO.
Elastics.cloud's composability solution is built on a new interconnect standard called Compute Express Link or CXL. CXL was invented to run on a PCI Express physical layer, and CXL enhances the protocol by addition of the .cache and .mem capability that was not supported in PCI Express. Accelerators, AI ASICs, and smart NICs and smart SSDs require cache coherency in hardware while supporting direct data path among the components, avoiding costly route through CPU in the system. CXL allows you to create multiple pools of resources and then allocate and deallocate them based on the workload that is running on the server CPU. So when the workload requires n number of GPUs or n number of SSDs or hundreds of terabytes of memory, it doesn't matter where those components reside, we can compose a server based on CXL. The first step in the composability evolution is memory disaggregation and pooling. Let's look at our first composable infrastructure where we demonstrate the composability of the memory.
In our first demonstration, we're showing how Elastics.cloud technology can enable devices to access a locally attached memory pool over a CXL connection. We're running an Intel Sapphire Rapids server with a CXL endpoint. A protocol analyzer is inspecting the traffic between the processor and the CXL endpoint. Let's use some diagrams to show what's happening behind the scenes. Here we see a diagram of a server with 4 unused and isolated memory pools in gray attached to a PCI Express device. Now, let's see what we can do if the device is using Elastics.cloud technology built on CXL. The blue color represents our unassigned and available memory pool that can be shared among many different workloads. The memory can now be accessed when needed. Memory from the CXL pool is reassigned to the processor. The software running in the workload can now seamlessly access the newly assigned memory. The actual data flow happens on the CXL connection between the processor and the endpoint, as confirmed by the protocol analyzer. In our second scenario, we'll show how Elastics.cloud enables memory expansion using a remote appliance. The same approach could be used to access many terabytes of data. Here, we've taken our initial setup and created a memory pool across a CXL backplane to a memory appliance with Global Fabric Attached Memory, or GFAM. Let's see what's happening behind the scenes. Our memory appliance has DDR memory attached to the GFAM. DDR memory connected to the GFAM is added to the memory pool. Once again, memory from the CXL pool is reassigned to the processor running the workload. The software running in the workload can freely access its assigned memory, including that which was recently assigned from the CXL pool. The actual data flow on the CXL connection between the processor and endpoint and across the backplane to the appliance can be confirmed by the protocol analyzer.
Memory pooling is just the first step in a longer-term vision of providing our customers the ultimate in flexibility and composability. We have assembled a team of pioneers and inventors with deep knowledge of interconnects and systems to leverage a new open standard to create heterogeneous, composable systems that will revolutionize systems design. As data continues to grow, so too must we to gain insight through more robust architectures.